those get nasty. Those get so nasty. I'm going to start playing as you guys are talking, if that's okay.
Oh. I saw that one. And then the one with the inflatable. And then there's this one that eats like plastic. That's the one. That's the one.
The one where the girl only wears green, the old lady.
Yes.
That's such a good show. There was one where this girl only ate fries. She only ate fries.
That's not that.
No,
That's not
she
that
tried
weird.
to eat something else and like she like.
Oh wait, no.
She
Wait.
only eats fries.
Yeah, the cheesy potatoes.
That's me.
She only eats cheesy potatoes for like the last 10 years. And wasn't she like 500 pounds?
She was like skinny or something. And
No, she was not.
She was like microwaving it and she's like, I have to eat it. And she's like, so on it and stuff. It's so weird. I have to eat it.
And then she gagged. I remember that. Just smelling it.
I love that show. Have you seen this once? I don't think it's on that show. But like she's trying to lose weight and she like has cheese and broccoli on her plate. I can't do it. Oh, like my 600-pound life or whatever.
Oh my gosh, I watched that.
Those are really sad.
And that show is so uncomfortable. I come home and ask my mom to watch it.
And it's like, we're like, talking about what to eat for breakfast. She's like, first I make pancakes, then I make some eggs, then I eat toast, then I have cereal, then I make some oatmeal. I'm
There's a broccoli in there, it's all over.
I can't. That's me.
Dun, 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 dun. All right. In more ways than one. Guys, you get slowing down to the left and speeding up to the right?
Yes.
Slowing down, moving to the left on 0 to 2, and speeding up, moving to the right on 2 to infinity. Why did my sign chart stop at 0? Yeah, hopefully self-explanatory, right? Hopefully self-explanatory. Where's the initial position? Like, where does it actually start from? Not 0, 0, 0, 3. So technically, if we want to think about it, what's actually going on, this little guy on an x-axis, 1, 2, 3, he's starting here, like a little point on the axis, one-dimensional motion, right? And from 0 to 2, which is kind of weird, that means he's starting with an initial velocity of -4, so he's like being shot out, which is opposite, because it's not shot out, he wouldn't be slowing down. But somehow he's slowing down, moving to the left, and then all of a sudden he speeds up as he moves to the right. And in between, you have a stationary point, right, where he momentarily is stopped. Okay, what problem did I not have you guys do? It was this guy, and he was a graph of who? Who is this a graph of? Yeah, that's what I thought too. It would be a much better problem if it was, but it's actually not. It's just the graph of position. Yeah. So when they ask you something like, when is the velocity equal to 0 given a position graph, altogether, what would we answer? Max and min. So then we'd have to go ahead and kind of estimate the max and min, which I don't like. AP graphs would actually show us where they're at, which is why I'm not specifically going to have us answer this one or even really write it down. Guys, is that a 0? No, it looks slanted, right? This one's a 0, though. That one's a 0. So there'd be, what, 4 different velocities equal to 0? I just don't like the question because it wasn't very precise. Because it's asking at approximately what times. That's gross. AP would give it to you. And then when is acceleration equal to 0?
How do you know this? Like on homework, there's a lot where they give you the original and then they ask you to find F double prime.
Is when the concavity changes?
But how do you?
Yeah, points of inflection.
So only goes negative, positive?
Because we'll check it. Check it, check it. IVT. No. Because F prime would be the tangent lines. But think F double prime from a position graph. F double prime is concavity. So what's F double prime sign for this portion of the graph? Positive. And then F double prime sign is negative. IVT, what has to happen in between at the point of inflection? A 0. Now you have to approximate, which once again I think is kind of gross. We could go ahead and approximate there, but that could be for, let's change the colors real quick. Like there-ish. Ish. I mean, I guess I could do a little bit better approximation, but I'm thinking this distance about cut in half. Wait. Concave down, concave up. There's another one here-ish. Right? Concave down, concave up. Concave up, concave down, here-ish. Concave down, concave up, here-ish. Concave up, concave down, here-ish. Yeah, that's okay. But you have to go in the middle of each of the concavities. See the down, up, and then the up, down, and then the down. But it's going to occur, it meaning acceleration equaling to 0, aka inflection points of the original function, are going to occur when concavity is changing. And some of it's slight, like this one, that was slight, but still a point of inflection. Does that make sense, guys? Yeah.
How do we tell the difference between, so if they give you the original function, you can only find actual points of inflection. You can't find possible points of inflection, right?
Right. Right.
Wait, because if on the original graph, if it's like concave up and it like flattens out and then it's still concave up, is that an actual possible?
Right, but what will a possible inflection point look like that's not an actual? That's what she's asking. Because all the actual were possible, but are there any other possible that aren't actual? No, because it goes concave up in between, yeah. Because it's an actual. Good thought, though.
What would that look like?
I knew you were going to ask that. I was already thinking of it. Well, let's just think of an example function. I think of things more algebraically than I do graphically, to be totally honest, so you guys need to help me out. Let's think of a function whose second derivative equals 0 but doesn't change sign. And what I think of is a squared function, right? So what if our f double prime of x was equal to something like x minus 4 quantity squared, right? It's not going to change signs before or after 4. But where did this guy come from? Well, what would f single prime have been? Because that's what we're trying to think of, right? What the original function looks like. F single prime would have been, you guys know how to do this, even though it's u sub, and we're going to kind of cheat a little bit. I gave you a nice u where du is 1. Isn't that just going to be x minus 4 quantity cubed times 1/3? Right? And the single one would be 1/12. Technically plus c, technically plus c. What's going on with this guy? Weird, right? Now, is every vertex of every even degree polynomial always going to be a possible inflection point? So graphically, that's where it gets hard, because this could just be an x squared, and an x squared isn't going to have a possible inflection point at the vertex, because it's going to be a constant by that point. But that's one example, and x to the 4th, x to the 6th, x to the 8th, when it's derived twice, will always have a possible inflection point that isn't an actual. That's just one example, though. We could think of maybe square root functions, because those will always be positive on either side as long as the domain, is still intact. Or you can go on either side and still be within the domain. What else is always going to be positive? Absolute value function. But long story short, yeah, Maggie, I don't think we can see the possible inflection points without knowing the function that aren't actual. Let's save that. Ooh. Ooh. I like optimization, but not as much as related rates. Okay, section 5.3, let's grade quick. We're going to section 5.4, optimization. Maybe some of you are extra thankful for those that spoke out and said, can we have till Monday? Anyway. Just so you guys know what the rest of chapter 5 is. Optimization is the whole maximize, minimize, basically.
I never learned this.
Well, but isn't the long story short, finding the max min, just you got to make your own equations and use clues? Like,
Yes.
you're really finding the first derivative and using either the first derivative sign chart or second derivative sign chart.
I'm just kind of afraid it wasn't on the test.
No?
No. Me neither.
I think we were like really quickly last year.
Last year, I take time on optimization in AB. Is it really just because it's not a forever card? I mean, related rates wasn't a forever card either. You guys remember that.
Every time I got to a question, I was bad at it.
That said max or min? You skipped every max min question?
No, optimization.
It's just max min questions with words.
I just pretty wasn't on the exam. It wasn't. So we got like.
Oh, I didn't know we started grading. Sorry. Yeah, Maggie, what's up?
It wasn't continuous.
Yeah, that's what I could see.
If you plug in 0 for the originals, the limit as x approaches 0 from the right, and the limit as x approaches 0 from the left, it's 3 does not equal 1.
Exactly, so it's not
So I put, because it's not continuous, it is not differentiable, and therefore has external. Yeah, okay.
But it was not an undefined point. So you're right, it was not differentiable, which means the derivative does not exist, but the domain, which is what I keep on going back. I say look for discontinuities, but I say check the domain. Was x equals 0 in the domain of the original function? Yes. Is it a local minimum? According to our book, yes. Because it states on the domain of the left piece, or even for the region around, it is a low point, even though there is a break in the graph. What was the original function? A quadratic coming in and a quadratic going out? Oh, I can't do that. Struggle. Going into 0? Greater than? Less? Sorry, less.
3 minus x squared for more to the right of 0. So.
Oh, to the right of 0.
Actually, no. Did I write this wrong? No, I think you're good.
Greater than or equal to? Less than or,
Yeah,
or
less
equal to? Or less than?
Less than. Just
Okay.
not.
And then,
X squared plus 1. Oh, there.
okay. Here's the struggle. Is this a minimum for the region directly around it? Our book says technically yes, and technically it is yes. The domain does exist there. It's not an undefined point. Yes, it's discontinuous, but it's not undefined. The derivative does not exist, which is a critical number.
If we do a sign chart? Oh, I guess, yeah, I guess.
Because it's increasing and increasing, so the sign chart,
That's negative to positive.
right. So remember how our book sometimes defines things a little differently than the AP does? According to them, they would say, yes, there is a local min at that point. For our purposes, I'm totally okay if you said none. According to the AP, you would not be wrong because there's no sign change in the first derivative, right? It's increasing then increasing. But do you see why our book is saying yes, but the nature of the curve, technically that is a low point for the region around it. Technically, yeah, it is a low point. I know. Yeah, Justin.
So like, although like that's like the minimum for that region, like how do you determine the region? Because I could just go like a little to the left and say like, look, that point that's lower is actually the local minimum. So like, can you just always
Because
say, like,
critical numbers.
So it has to be proved.
Yeah.
Okay.
So an undefined or a 0 of the first derivative. Yeah. Our first and second derivative tests are based on continuous functions. So Maggie, technically, how they get around calling this a local minimum is that they say the first and second derivative tests are only for continuous functions. This is discontinuous, so therefore the first or second derivative tests could not apply or don't apply, in a sense. So they're doing an exception. Not an exception, like the first second derivative test technically doesn't apply, but for numbers, you can just be bitter at the book, it's okay. It's technically a little bit better for like college math, but for the AP, it goes a little deeper than the questions that we go into, or that the College Board gives us. For number 10, were you guys just analyzing concavity? Oh, okay.
I have A as negative infinity to 0 and then B as 0 to infinity.
Did you guys just switch it? What was actually being asked?
The A was concave up and B was concave down.
Do you guys switch your signs? Is that your second derivative?
Yeah, that's right.
So if you plug in a positive, the root doesn't really matter. It's still going to pop out a positive even though it's in a denominator. And then if you put in a negative, an odd power root is going to pop out a negative. Maybe you guys were like multiplying by that guy for some reason? Is that what was going on? So you had positive then negative. Is that what happened? Yeah, if you do a negative, you're going to get a negative. Oh, no, the first derivative was negative. The second derivative, when it pops down, is a positive. So if you put in a positive over a negative is a negative. And if you put in a positive over a positive. The first derivative is positive.
Yeah. Down to the right.
Right?
It's concave down from negative infinity to 0, right?
Yeah, infinity to 0 is concave down.
That's what I put.
That's what I have.
You guys said concave up, concave down. Oh, you're used to answering down first and then up? Is that what happened?
I don't know.
That's what my sign looks like.
But you guys,
I got it right. I got the derivative right.
you guys read to me this directions, right? Concave up and then concave down?
Why do I have the same homework?
Cheat us. Just kidding. Keep going.
No, I did this on Wednesday. I thought it was due on Wednesday.
Do you guys get it? I think we're testing increasing, decreasing now, right? So a local min. So decreasing on negative infinity to negative 2. Now wait. We know better. How do we put our intervals? Closed or open with increasing, decreasing? Open. Yeah, no. Keep them open. Don't follow the book on this one. Keep them open. Local max at 2, local min at negative 2. So your sign chart should have been negative, positive, negative, right? Good. Number 28, take the velocity and take the acceleration for A and then for B. They describe the motion kind of like I did. I didn't quite do it in the same order, but they asked what the initial position was. It starts moving in the positive direction until it... Now they went ahead and split up the journey and were like, oh, guess what? And it's at position 1. That's fine. Do they even do speeding up, slowing down? Slackers.
No, I didn't do that one either.
You didn't do speeding up, slowing down?
No, but I did do.
So it starts moving to the right from 0. And we could test it real quick, right? Time equals 1. That would be... That's 0. 1/2. 1/2 is 3. 1/2 is 0. I have to do a sign chart. If you guys didn't do speeding up, slowing down, we won't even check it. That's okay. What are we asking about? Number 38? Do you guys see how to do the quadratic formula? Oh, x equals negative b plus or minus square root b squared minus 4ac.
I have the prime of x and I realized it was going to take
Yeah, Kathy.
and I was like,
About 6 thing. You have
Yeah.
So when it's any
Velocity,
basically like anything with that has to do with
a first derivative.
graph in terms of like another antiderivative. Would there ever be a case where you would have to use closed? I think I just
On a graph, yes, because on a graph you could have something where
Love that.
Just take it now.
if there's an endpoint that has a positive derivative, it would need to be included in the increasing, or vice versa, decreasing interval. Yeah. Yes, they're actually back there graded. You guys get it? A, local max at 2, B, local min at 4, points of inflection at 1, 1.63. Oh, that's gross. Don't do that. 5 plus or minus the root 3 over 2. Local max at 2, local min at 4, points of inflection at 1, and then 5 over 2. We're good? Any more evens, guys? 58 is A. All right, any questions, odds or evens? 58? Okay. Anything else besides 58, odds or evens? Why? Why do you sign out? Okay, anything else besides 58 as I pull it up? Worked so hard. Pull it up. It just showed up and then it disappeared again. Silly book. Here we go. All right, 58. Why don't you guys? Yeah. Go back. Hey guys, you had a question. I'm here. I apologize. I was signed into the book. Life happens. Okay, so what'd you guys first realize that you were supposed to be looking? Which of the following enable you to conclude the graph of f has a point of inflection? Stop. Point of inflection. Think. What has to be true? F double prime has to change signs. That could also be seen as f prime changing behavior. Right?
I put A in.
No, it's the sign is not the same. The sign of f prime is
Because this is a condition.
The sign of f prime talks about f's behavior. The sign of f prime changing results in f decreasing, decreasing, increasing. That's relative extrema of f. That's relative extrema of f. The second derivative not existing, that's possible, not actual. Second derivative equals 0, that's possible, not actual. A local max, that would be f prime changing from increasing to decreasing. I apologize. No, that's right. Yeah, thank you, thank you. A local max means f prime changes from increasing to decreasing, aka f double prime changes from positive to negative, aka a definite sign change. Another way of looking at it, the slopes of f prime will change from positive to negative.
But if the sign of f changes at x equals c, doesn't that mean that it's a point of inflection?
the sign of f prime.
The sign of f prime.
The sign of
It has to be the sign of the slope of that.
because it's the double.
Not a point of inflection, but f prime is changing sign.
That's
The slopes are changed,
But if slopes going in
but positive to
inflection.
negative.
but that's not compatible.
That's not a point of inflection. That's a relative max of f. A point of inflection,
Oh, well, if that happens.
there will be somewhere maybe else. Somewhere else. Does that make sense? Yeah. You tend to, as far as I can tell, Riley, you tend to like tie together concavities, like as far as what you think is happening around. You just have to get a little bit more precise in how you're defining things. Does that make sense?
Yeah.
Yeah. So you do have concave down, and if there is a concave up later, there will be a point of inflection coming. But slopes don't necessarily change signs before and after a point of inflection. Does that make sense? Yeah. Okay. But if I'm looking at f prime having a max, then all of a sudden I can say, well, the slopes, if f prime is changing, then f double prime would change. and now I'm good. That's why this one is the only. Yeah. Okay. Whew. All right, so that was it on homework. Going once, going twice. Optimization, the topic that very few of us even know we learned last year. Okay, so go team. Come on. It was the first time we did burrs. Yeah. This is the Blue's Clues section. I'll go back to my calendar as soon as I get this up and you guys start taking notes. Issa, go ahead. What's up? Can you just put it on the whiteboard tray? Let's see. Section 5.4 is optimization. Section 5.5 is linearization, aka differentials. Approximating with a tangent line. So section 5.4 is finding the max and min of word problems. Section 5.5 is approximating with a tangent line, and section 5.6 is related rates. This was the end of semester 1. Well, not technically the end. The end, I suppose, was 15 identifies. Wasn't it? I think that was the end. What's a mile and a half? Oh.
That was so good.
Literally.
It was so bad.
Every 10, like 10, 20, and 30-yard line. And then they're coming back. And then crocodile walks.
Yeah, and then my coach was like, oh, we should do that.
Drop one of the ceramic crocodiles just made and then
Because they were goofing around.
yeah, and then got kicked out of room 130 and then table like sick of this.
I've had enough.
That's what's cool about sports teams, though. You learn discipline.
Thank God I quit. I know. I see soccer practicing. I'm like, thank God.
I know. I feel that.
All right, what's your question?
Oh, I know Kathy already asked me this, but I just wanted to say, are we getting tests at the end of the period? I just really want to see what they got. I didn't know I got like.
I'll see if I can do end of the period. The problem is I had to supervise pre-calc. You don't need to know why. They're not written down in the grade book yet, hence the dilemma.
Could we like see what we got after class?
Possibly. I mean, yeah, I can show you the score. You can even take the test as long as I write it down. Let's just say we had a lot of A's and B's. Actually, we had only A's and B's. Only A's and B's. Clue words. Guys, think of a word problem. Think of a word problem. When would you need to do something to do with max or min? Wording.
The highest point.
Maybe.
It's like,
Probably not.
the lowest point.
Lowest. Yeah, what else?
Highest.
Highest. What else?
Highest.
Smallest.
Smallest, largest. What else?
Farthest. Closest.
Ooh, that one's a good one. Because that's minimizing and maximizing distance. Distance formula.
Fastest, slowest.
Issa says right, left.
No, rightist, leftist.
No. That does show up in AP, but they don't put it that way. How do they put it? Most to the right, most to the left, or furthest to the right.
So it's not something.
Left and right.
They have done that before, though.
Oh dear. Rightist.
This year they're going to say something with polar. Ooh! Thank you. Respond as bad as my dog. That's not his whistle, though. But anyway, coming back. This time you're going to have with polar curves. Same idea, but it's going to be farthest from the origin. Because the radius, anyway, maximizing the radius of polar curves. Anything else? Probably just minimizing, maximizing, right? Minimum, maximum. So this entire section is what do you do when you see these clue words in a word problem? Yeah. We didn't really use the word optimization. I didn't make a big deal about it. I mean, I did. I said it. I said it every single time. It was a max or min problem. But the long story short was max, min. We learned what they were before we ever learned the word optimization. It's just like, hey, when does max, min show up in a word problem? What do? You read it. You translate into math anything you're given. You try to write mathematically the given and the find. What do you have and what are you supposed to find? Is there an extra Is there an extra clue that you're going to have to manipulate, play with, plug in, etc., substitute for to be able to take the derivative? Oh, wrong one. Wrong one. Primary equation is the one that you have to take the derivative of, the one that you care about, maximizing or minimizing. 4 is watch out for domain. 5 is use calculus to find a max or min. Good news is, as of Tuesday, I'm officially signed up for a Saturday math conference, Go Team, in November. That has a lot of calculus workshops, a lot of calculus sessions, all having to do with the 2018 exam and the changes as to how they're grading. So, nice thing is we'll be nice and up to date in things that you guys have been asking as far as, or I've been bringing up, like with L'Hopital's, etc. And yes, even Mr. Calculus is there, but I'm not sure I'm going to the session. I think it's more just the stuff I've already learned from him. You guys want to come? Palm Springs, November 2nd, 3rd? I'll peek at it. I'll peek at it. How did this get into an Airbnb? I have no idea. I was going to leave at like 4:30 in the morning. No, they're great ones. I agree. Well, you guys didn't really have to, like, I don't know. Once you start adulting, you'll start learning things like that.
Wait, can students go?
There is like a student. I'll look it up. I'll see.
I'll definitely go.
I'm
The
so
little
down.
AC on the side.
I could send you guys to all the calculus workshops, and I could go do all the department chair workshops.
Yeah, and then we could just take notes and.
But the problem is it does cost money, so hence the dilemma. I'll go look. There's like a student, and then maybe I'll have you guys volunteer, and then you can get cheaper. Then it costs more.
We're teachers.
Put on my resume. I volunteered.
Oh my god.
Oh my god, my application.
Oh my goodness. Okay, be quiet. I really don't know if this is going to work out. This is way too last minute.
I have a random off-topic question. Are you coming up?
Yes.
Yay! That's the whole system.
I go on the
How do they do
seniors.
the little letters thing? Like where you write, like, your parents like write letters? Do they not do that anymore?
You're not supposed to know that.
Whoa.
What? It's
Bro,
supposed to be a
it's a bad-
surprise.
Oh my, he's gonna want his parents to know.
To be honest, I don't know how they're doing the senior retreat.
Oh,
I have been involved in the past when it first started on South Campus many moons ago with Mr. Strike. I was involved in the leadership as far as putting it together, but that since has transferred to other hands, so I literally am just there to try to support you guys in the midst of anything and everything that happens. It's a good way of putting it, right? Okay. James. Okay, can we go?
I'm not going to be singing.
Huh?
She's going to be singing because there's 2 retreats at the same time.
I do not believe that one worship person can be in 2 places at once as far as I know.
What do you think she's going to choose?
I really hope she doesn't.
I don't know if they're going to try to stagger sessions. Like, I honestly don't know. So
Everyone's like, no, you should really go to that.
No, we'll take one for the team that you guys can have. You guys need the Lord.
anything and everything you guys want to.
Yes.
Coming back.
Are we doing my favorite?
Not tomorrow.
Not tomorrow. Not tomorrow. So excited. We have homecoming. What? Productive class? Or you mean unproductive class?
Yeah, no, seriously, this is like the class I would.
I know AP Gov, I just like sit there and listen to him lecture.
Okay, we're going on so many topics. Shush. Let's go.
I'm so excited.
We love math.
Let's talk about how productive we are. We're not being productive. Question. Why? What do we have to take a derivative of?
Surface area. The equation S.
V. We need V. Maximize volume, right? So, hold on. How do we maximize volume? We need to maximize the volume equation. What's the volume equation of a cube?
H cubed.
Well, it would be x cubed. It's kind of small. Actually, I apologize. It's a rectangular solid. X, X, and H. So therefore, wouldn't the volume be x squared H? Length times width times height? Thanks. Go team. What's the problem of taking a derivative right now?
There's like 3 variables.
And implicit differentiation is a thing, but this is not taking like derivatives with respect to related rates. It's not. I don't know. So, we have to go look for a clue. Riley, why'd you say surface area a second ago? Yeah, exactly. It's there. Why is it there? Because the surface area of this box, which is 4 faces of x times h, 4 of those, 1, 2, 3, and 4, there are 4 faces of x times h, and actually they give you the formula, little cheaters. Yeah, 1, 2, 3, 4. No, that's a different dimension because this is a square base. So this one's going to be x squared equals my surface area. And didn't they tell me the surface area is 108? Come on, mathematicians.
Yes.
What's the easiest variable to solve for?
4x.
H, please, right? Isn't h a lot easier because I can do 108 minus x squared all over 4x equals h? Yeah.
Wouldn't it be 2x squared? Is it talking about?
No, it's an open box.
I can't read.
No lid. It's okay. It's okay. We got distracted with many exciting things. At least one of which, Friday lunch, might actually happen. Okay, so. It's okay to be sad and happy all at the same time. Is that tonight?
It's the last one. He's like hyping himself up. What's going on?
Why am I here?
I've already cleared my first.
Why am I here?
I need 2 credits. I need to college. I need government. I need like another year of English. That's it.
Guys, what am I doing right now?
You're solving.
Yeah. I'm simplifying it so I can make a much easier derivative, and then I'm making the derivative itself, right? What do we have to do if we're trying to maximize the volume? Critical numbers. Good, Eric. In critical numbers, wouldn't I go ahead and add the 108 over 4, multiply the 4, which cancels out, divide by 3, which ends up being 36, and then taking the plus or minus square root? Wait a minute. Why does the negative 6 not make sense?
You can't have a negative.
Can't have a negative. What's the dimension? I don't know. Feet, inches, something, 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 something up above. Optimization. Vaguely. Long story short, you have to somehow find a max or find a min. Of what? I don't know. Read the problem and figure out what it is. But what if you can't take a derivative outright? Go look for a clue. There's going to be something hiding where we can plug and get rid of a variable. Nice thing is, Sally, we even did this in pre-cal where we do some substitute. We just weren't taking derivatives yet. But they had clues too. It was just trying to simplify equations in terms of one variable, function of x. So what would happen if you see something like closest, minimize the distance formula? What if they say something about maximize profit? Figure out the profit formula and take a derivative. Optimization. The reason why you don't remember the name is because hopefully it's just doing good math with calculus knowledge. How do you find max or mins of things? Take derivatives. What if you don't have enough information? It's somewhere else in the problem. Don't make it up, but find it and then use it. Find it and then use it. So to that end, let's go ahead and zoom in on the minimum distance one because that's the one a lot of people don't like. How do I make an equation to take a derivative of? How do I make an equation to take a derivative of? What's the distance formula?
Oh, v equals the square root of x squared plus y, x plus y.
X minus x1 squared plus y minus y1 squared. Ew, gross! I don't want to take that derivative. Wait, I can't. Yes, you can. Go plug him in. I still don't want to take that derivative. Remember last year that the minimum d is also the location of the minimum of d squared? Why do I want to square both sides and then minimize? Don't have to deal with the square root, but both ways work. That's just a hint. That's just a clue. Homework could be due tomorrow, but we'll make it due on Monday. I'll go change it. Bye. I thought we were doing the thing that you guys talked about, our cultural calculus club.